Hello friends, I welcome you on my channel Engineering Mathematics DJ Ganit. Today we are going to discuss one important topic of calculus known as partial derivatives. So in this lecture we will introduce partial derivatives, we will define partial derivatives, and we will understand how to calculate partial derivatives of a given function. So let's start with what we mean by partial derivatives. So you are familiar with derivative from your school. We know that if we have function of only one variable, say g of x, suppose y is a function of only one variable x, then the derivative of this function at some fixed point, say a, the derivative of this function gx at point a is denoted by g dash a if it exists, and as we know it is defined using this limit h tends to 0, g of a plus h minus g of a over h. So this is the derivative of a function of one variable. So this type of derivative is known as ordinary derivative, which you study at your school. Ordinary derivative means we are considering function of only one variable, say y is a function of x here. Now suppose we have function of two variables, say z is a function of two variables x and y. Then here whenever there is a change in x as well as in y, there will be a change in f or z. So z depends on the x and y both, or change in z depends on x as well as on y. So here we have the concept of partial derivatives. If we have function of only one variable, then derivative is ordinary derivative. But if we have function of more than one variables, either 2, 3 or finite number of variables. So here u is a function of three variables, here z is a function of two variables x and y. So whenever we have functions of more than one variable, we have partial derivatives. Now we understand meaning of partial derivative. Suppose in this function of two variables x and y, we vary this variable. We assume that variable x changes and y becomes fixed. X changes and y is fixed. We fix y and we assume that x varies. So suppose value of y is constant, say y equal to b. So if we consider y as constant, then we have this function becomes x comma b. We assume that y becomes constant and x changes. So if we consider y constant, then this is nothing but function of only one variable, say h of x. So now hx is a function of only one variable because we have taken y as constant. So we can talk about ordinary derivative of this function hx, because hx is a function of only one variable. So we can talk about ordinary derivative of hx at some fixed point, say a. So using this definition 1, we can write the derivative of this function hx at point a. So we will not use h here, h is used in the definition. So we consider some another function, say p of x. So derivative of this function px at point a is nothing but, using definition of ordinary derivative, it is p of a plus h minus p of a divided by h. Now if we put value of p of a and p of a plus h here, we have limit h tending to 0. Here h, p of a is value of function at point ab. Okay, we put x equal to a here, so we obtain value of p at point a. Similarly, if we put x equal to a plus h here, we have f of a plus h comma b. So this derivative of px at point a, this derivative p dash a, is nothing but partial derivative of this function fxy at point ab. So this p dash a is, or we can write p dash a equal to d by dx of function of one variable at point x equal to a. So ordinary derivative of function of two variables considering y as constant, say y equal to b. So this ordinary derivative considering one variable as constant is called partial derivative of this function fxy with respect to variable x at point ab. So it is simply generalization, and it is denoted by, we will use this notation, partial derivative of fx with respect to partial derivative of f with respect to x at point ab, or we can denote it in this way also, del f by del x at point ab, or because we have written z equal to fxy, we can write del z by del x at point ab. So in this way we can define partial derivative with respect to x. So here we are using the definition of ordinary derivative. Partial derivative is one type of ordinary derivative, but it is for functions of more than one variable. So once we consider one variable as constant and another variable is changing, then that function becomes function of only one variable. So using definition of ordinary derivative, we can define partial derivatives in this way. So here, as we have seen, if we consider y as constant, say y equal to b, then this function of two variables is converted into function of only one variable. It becomes function of x. So we know definition of ordinary derivative at point a, so we use that definition, and then putting values of px in terms of fxy, we obtain this definition. So similarly we can define partial derivative with respect to y also. So in that case we will consider x as constant. If we want to define partial derivative of this function with respect to y, we consider x as constant, say x equal to a, and we assume that y varies. So in that case the definition will be limit h tending to 0. Now x becomes fixed a, and we are interested in the derivative at point b. So here we write f of a b plus h minus f of ab divided by h. So this is nothing but partial derivative of function f with respect to y at point ab. So partial derivatives of function of more than one variable are nothing but ordinary derivatives by keeping another variables constant. if I am interested in the partial derivative of this function of three variables with respect to z, I will keep x and y as constant. So this will be a function of z only, and I know how to find out ordinary derivative of this function with respect to z. So at that time I will consider x and y as constant. So partial derivatives of functions of more than one variables are nothing but ordinary derivatives with respect to one variable, treating remaining variables as constant. So now we write down the definition. The partial derivative of function of two variable xy with respect to x at point AB is defined as this limit of f of a plus hb minus f of ab divided by h. Here we are defining partial derivative with respect to x, so we consider y equal to b, that is we consider y as constant, and we use the definition of ordinary derivative with respect to x. If this limit exists, then this partial derivative exists. Similarly, the partial derivative of fxy with respect to y at this point is given by this limit. Here we assume that x is constant and y changes. So we write x equal to a, x is constant, say x equal to a, and we assume that there is a change in y. So here we write f of a comma b plus h minus f of ab divided by h. So if this limit exists, then partial derivative exists at given point. We can use these different notations for partial derivatives. Partial derivative of fxy with respect to x at point AB is denoted by this notation, or as we discussed, it is nothing but ordinary derivative of function of two variables considering y as constant. So we can write it in this way also. Similarly, if we want to write down partial derivative with respect to y, then we write in this way. Instead of x, we will write down y, and we consider x as constant, y changes. So here we write y x equal to at point y equal to b, because x is constant, say x equal to a, and we are interested in the derivative with respect to y. This is another notation. These two are same. We can write in this way also. This partial derivative can be written in this way also. Similarly, partial derivative with respect to y can be written as f suffix y at point AB. If fxy equal to z, then we can write z in place of f also. Both are the same. These are another notations. These are partial derivatives at any point xy. Del f by del x can be written as f suffix x, or if fxy equal to z, we can write z suffix x. Here also we can write del z by del x, or partial derivative of fxy with respect to x. And these are similar derivatives with respect to y. So now as we discussed, to find out partial derivatives with respect to one variable, we will consider another variables as constant. So if I want to find out partial derivatives of this z, which is a function of two variables, so to find out partial derivative with respect to x, I will consider y as constant, and I take derivative of fxy with respect to x. So that is, if I consider y as constant, f will be a function of only one variable. So ordinary derivative of this function with respect to x is nothing but partial derivative with respect to x. So to differentiate or to find out partial derivative of fxy with respect to x, we will consider y as constant, and then we will find out ordinary derivative of function of one variable. Similarly, to find out partial derivative of f with respect to y, we will consider x as constant and we differentiate fxy with respect to y. So here we will use the formulas of ordinary derivatives. If I have function of three variables, say f of x, y, z, then I will have three partial derivatives of first order. This del f by del x, del f by del y are called first order partial derivatives. So here we have three partial derivatives of first order. So if I am interested in the partial derivative with respect to x, I will consider y and z as constant. Similarly, if I am interested in partial derivative with respect to z, I will consider x and y as constant, and then I will differentiate with respect to z. So in this way we can calculate partial derivatives. We just have to remember the formulas for ordinary derivatives which we have studied in our school level. So we consider some examples. Here we are given function of two variables x and y. So we try to find out partial derivatives of this function. So given function is fxy equal to x cube plus x square y cube minus 2y square, and we are asked to find out partial derivative of this function with respect to x and y at this point. So if we are interested in partial derivative with respect to x, we will consider y as constant. So we differentiate. First we differentiate x cube with respect to x, it is 3x square. Now in this case y is constant, therefore y cube is constant and derivative of x square is 2x, and because y is constant this term becomes constant, so derivative of this constant term is 0. So this is derivative with respect to x, 3x square plus 2x y cube. So therefore we are interested in the partial derivative at point 2, 1. So we put x equal to 2 and y equal to 1. So here x is 2, y is 1. So this is going to be 3 into 4 plus 2 into 2, that is 12 plus 4, which is 16. So it is very easy. We are using the formulas of ordinary derivatives, but we consider y as constant because we are differentiating with respect to x. So in first term there is no y, so derivative of x cube is 3x square. In second term y cube is constant, so we consider y cube as it is, derivative of x square is 2x. In the last term there is no x, so this whole term becomes constant and derivative of constant term is 0. Similarly, we can find out partial derivative with respect to y. So now we consider x as constant, so therefore x cube is constant, so first term becomes constant, so derivative is 0. In second term x square is constant, so we keep x square as it is, and ordinary derivative of y cube is 3y square. In last term this 2 is constant, derivative of y square is 2y. So this is nothing but 3x square y square minus 4y. Therefore partial derivative of f with respect to y. These are different notations for the same partial derivative, and we are interested in the partial derivative at point 2, 1. So we put x equal to 2, so 2 square, that is 4, 1 square, which is 1, 4 and 1. So this is nothing but 12 minus 4, which is 8. We consider one more example. fxy is x into cosine of x into y. So if we differentiate with respect to y, we will consider x as constant. So here we are asked to find out partial derivative with respect to y. So we consider x as constant and we differentiate this with respect to y. So we consider x as constant here. So x is constant, and to differentiate this we have to apply chain rule. So derivative of cosine function is minus sine, and in the product we have to write down partial derivative of x into y with respect to y. This is by chain rule. For we are applying the chain rule for ordinary derivatives because x is constant and derivative of cosine function is minus sine, and here we have to differentiate x into y with respect to y. So this I can rewrite as minus x sine xy. Here x is constant and derivative of y is 1. So finally it is going to be minus x square sine xy. So in this way we can have partial derivatives of functions of two variables. We can find out partial derivatives of functions of more than two variables also. Suppose I have x square into y into z square. Then if I want to find out partial derivative of f with respect to x, I will consider y and z as constant. So here y into z square becomes constant and derivative of x square is 2x. So it is 2xy z square. Similarly, if I am interested in the partial derivative of f with respect to y, I will consider x and z as constants. So I will have x square into z square and derivative of y is 1. So it is x square z square. Similarly, if I am interested in the partial derivative of this function with respect to z, I will consider x and y as constant. So this portion is constant and derivative of z square is 2z. So we have 2x square y into z. So we can generalize this concept of partial derivatives to the function of n number of variables. If we are interested in the partial derivative of f with respect to one variable, say x1, then we will consider remaining variables x2 to xn as constant, and we will consider ordinary derivative of function f with respect to x1 considering remaining variables as constant. So in this way we can easily find out partial derivatives of functions of more than one variables. So in next lecture we will discuss some more examples. I hope you like this lecture. Thank you very much.